Hi everyone, today I want to talk about dynamic programming or DP. So specifically, DP is a technique where we break a problem into sub-problems and store the results, the intermediate results, and reuse them to avoid repeating calculations. You can think of it as a trading space for time. So let me start with a classic example, the knapsack problem. Imagine you are going on a camping trip. Your backpack can carry only 10 kilograms, and you have several items like food, a tent, a sleeping bag, and some tools. Each item has a weight and a value. Your goal is to choose items so that the total value is maximized without exceeding the weight limit. And a straightforward brute force way would be to try every item as a first choice, then recursively check all combinations of the remaining items. But if you do this, you might notice that some combinations are calculated again and again. And this is where dynamic programming comes in. It helps us reuse previously computed results so we don't repeat our work. There are two common approaches. The first is top down, and the second is bottom up. In top-down DP, we start by asking what we want to compute and then recursively solve the necessary subproblems. It's kind of a lazy approach because we only fill the subproblems we actually need. In bottom-up DP, we start with the smallest subproblems, filling out a table systematically until we reach the final solution. In this way, we compute every possible subproblem once. When I first studied the knapsack algorithm, I was confused by the comparison we always do in the algorithm, which is take the maximum of current value plus the best we can get with the remaining capacity and the best without the current item. I thought if we add the current item, wasn't like the total weight always be bigger than not adding it? And why do we even need to have this comparison? And then I realized that in dynamic programming, the subproblem is actually given the first I minus one's items and the remaining capacity of W minus the current item's weight. What is the best value we can achieve? In other words, if we use some capacity for the current item, we want to figure out how to optimally combine the previous items um, in the remaining space. That's why we have to compare. Sometimes including the current item increases the total value, and sometimes it doesn't. And dynamic programming is used a lot in coding problems on LeetCode, such as longest common subsequence, longest increasing subsequence, and grid or path planning problems. But it's not just for coding interviews. In real life, dynamic programming appears everywhere. Shortest path problems like GK-sharp algorithm or Flood-Warshall, which all rely on the principle of optimal substructure. And resource allocation, such as portfolio optimization or advertising budget distribution. Even in natural language processing, for example, in speech recognition, sentence alignment, and also finding the optimal translation path for auto translation. And there are some small interactive example, like imagine that you're at the top left corner of a grid and you want to reach the bottom right corner. And you can only move right or down. Each cell has a score and you want your maximum total score. How would you approach it? And if you try every path, it takes too long. But with DP, you can compute the best score for each cell based on the cells above and to the left. Then when you reach the bottom right, you already know the maximum score. And this is exactly the power of dynamic programming. We break problems into subproblems, reuse the results, and find the optimal solutions efficiently. So here's something to think about. Can you um, think or imagine decision-making problems in your daily life, like packing, scheduling, or planning, where breaking down the total problem into sub-parts and remembering the best results would help you to find the optimal solution.